August 9, 1944, near Vire, France. Lieutenant Colonel William Lovelady stood before what Allied intelligence had been calling Germany's most dangerous tank, the Panzerkampfwagen Tiger Ausführung B, better known as the Tiger II or King Tiger. 70 tons of sloped armor that made every previous German tank look obsolete. A gun so powerful it could destroy Sherman tanks at ranges where American crews couldn't even see their killer. Everything about this machine radiated invincibility. Those massive overlapping road wheels that created the smoothest ride German tankers had ever experienced. That long 88mm KBUK 43 gun that extended nearly 20 feet from the turret face, the glacis armor sloped at 50 degrees, presenting the equivalent of 240mm of protection against incoming rounds. Wehrmacht propaganda proclaimed this the ultimate expression of German armored superiority. Allied tank crews who encountered them in Normandy reported something close to terror. Lovelady climbed onto the hull, examining the precision welds where armor plates met at calculated angles. The craftsmanship was undeniable. This wasn't crude battlefield engineering. This was automotive precision applied to military manufacturing. Every surface, every component suggested the kind of perfectionist approach that had made German engineering legendary. He pulled himself up to the commander's cupola and dropped into the turret. The controls felt solid. The optics were crystal clear. The gun's traverse mechanism moved smoothly despite the weapon's enormous size. Then, Lovelady noticed something in the combat logs the crew had abandoned when they'd fled. Transmission failure. Third gear inoperable. Maximum speed reduced to 12 kilometers per hour. Range limited to 43 kilometers before complete breakdown. The tank had been operational for exactly 9 days. 6 weeks later, at the British Army's testing facility in Chobham, England, Allied engineers would put this captured masterpiece through the same evaluation process they used on every enemy vehicle. What they discovered would shatter every assumption about the King Tiger's invincibility and reveal why Germany's most powerful tank was actually the worst weapon they could have built for the war they were fighting. The hedgerows of Normandy had turned tank warfare into a nightmare that violated every principle of armoured doctrine. American tank destroyers and British Fireflies prowled the bocage lanes, waiting for German armour to appear in the narrow gaps between ancient stone walls. German tanks, designed for the open steppes of Russia and the broad plains of North Africa, were being funneled into kill zones where their superior range and firepower meant nothing. On August 7, 1944, elements of the British 7th Armoured Division encountered a King Tiger from the 503rd Heavy Tank Battalion near the village of Vire. The massive tank had been positioned to cover a crossroads, its 88mm gun commanding approaches from 3 directions. British intelligence had been tracking King Tiger deployments since the first units appeared in Normandy on July 11th. Every encounter report described the same terrifying pattern. The German tank would engage at ranges exceeding 2,000 meters, where Allied return fire was ineffective. Sherman crews watched their armor-piercing rounds bounce harmlessly off the sloped frontal armor, while the 88mm gun turned their tanks into funeral pyres with single shots. But this King Tiger wasn't moving. British scouts approaching the crossroads through adjacent fields reported the tank sitting motionless in its defensive position, engine silent, crew apparently absent. Artillery observers called in smoke rounds to screen the approach, expecting the tank to come alive and begin engaging targets. Nothing happened. The King Tiger sat there like a monument, its long gun barrel tracking nothing, its engine cold. A reconnaissance team from the 7th Armoured crept forward through the smoke, expecting ambush at any moment. They found the King Tiger abandoned, its hatches open, tools and personal equipment scattered around the hull. The crew had fled so quickly they'd left ammunition in the ready racks and fuel in the tanks. More tellingly, they'd left a maintenance log that told the story of 9 days of escalating mechanical crisis. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Lieutenant Colonel Lovelady, commanding the British Technical Intelligence Unit attached to the 7th Armoured, arrived at the site on August 9th. He'd examined dozens of knocked-out German tanks during the Normandy campaign, documenting damage patterns and armour effectiveness. But an intact King Tiger, complete with operational systems and maintenance records, was unprecedented intelligence. This was exactly what Allied testing facilities had been requesting since the first King Tiger was identified in combat. The tank's combat logs painted a picture that contradicted everything intelligence reports had suggested about German engineering reliability. The King Tiger had been delivered to the 503rd Heavy Tank Battalion on July 29th, fresh from the Henschel factory in Kassel. It had covered exactly 61 kilometers during its 9 days of operation. The crew had reported transmission problems on August 2nd, just 4 days after receiving the vehicle. Third gear had failed completely on August 5th, forcing the crew to operate in second and fourth gears only. Maximum speed had dropped from 38 kilometers per hour to 12. Fuel consumption had nearly doubled as the stressed transmission, and engines struggled to move 70 tons through limited SAS gear ratios. Lovelady examined the power pack with the careful attention of someone who understood that mechanical reality often contradicted propaganda. The Maybach HL230 P30 engine, a V12 producing 690 horsepower, looked impressive in its compartment. German engineers had designed it specifically for the King Tiger, strengthening components to handle the massive tank's weight. But the transmission, the critical link between engine power and track movement, was already showing signs of catastrophic wear after minimal operation. The maintenance log detailed increasingly desperate attempts by German mechanics to keep the vehicle operational. Daily adjustments to gear linkages, constant monitoring of transmission oil temperature, restrictions on maximum speed and acceleration to prevent complete failure. The crew had been nursing a dying vehicle, managing its decline rather than employing it as the breakthrough weapon it was designed to be. Lovelady marked the King Tiger for immediate shipment to England. British intelligence wanted comprehensive analysis of German heavy tank technology, and this intact example would provide answers to questions that had been troubling Allied planners since Normandy. Could the King Tiger's transmission problems be repaired? Were they unique to this vehicle or systemic across the type? Most importantly, was Germany's most powerful tank actually combat effective? Or was it a sophisticated disaster disguised as technological superiority? By August 15th, the King Tiger was crated and loaded aboard a landing ship at Arromanches, part of a convoy carrying wounded soldiers back to England. German prisoners headed for interrogation camps, and one 70-ton tank that would help Allied engineers understand why German armour, despite its fearsome reputation, was losing the war. The vessel crossed the Channel on August 17th, docking at Southampton 2 days ahead of schedule. A specialised rail flat car carried the King Tiger to the British Army's vehicle testing facility in Chobham, Surrey, where it joined a collection of captured German equipment waiting for evaluation. Chobham had been testing military vehicles since 1937, refining the process into systematic science that measured everything from acceleration times to parts count. The King Tiger arrived on August 23rd. Testing would begin the following Monday, giving technicians time to inspect the vehicle and prepare test protocols. Chief Engineer Robert Pritchard, a former Rolls-Royce automotive specialist who'd enlisted after Dunkirk, drew the assignment. He'd tested everything from Volkswagen Kübelwagens to Panther tanks, documenting the gap between German propaganda and mechanical reality. Pritchard knew the pattern. German vehicles looked impressive until subjected to sustained operation under field conditions. Complex systems that worked beautifully in controlled environments failed catastrophically when stressed by combat demands. But the King Tiger represented something different. This wasn't just another enemy tank. This was supposedly the pinnacle of German armoured engineering, the weapon that would stop Allied advances through sheer technological superiority. The massive tank sat in Chobham's receiving yard, its sloped armour gleaming in the late August sun. Those carefully calculated angles that maximised effective thickness against incoming rounds, those enormous road wheels that distributed 70 tons across tracks, wide enough to lower ground pressure despite the immense weight. the long 88mm gun that could destroy any Allied tank at distances that made return fire suicidal. It looked exactly like what German propaganda claimed it was. The ultimate tank, invincible, unstoppable, superior in every way to anything Allied factories could produce. Tomorrow, Pritchard and his team would discover whether looking invincible and being combat effective were the same thing. They would measure acceleration and top speed. They would calculate fuel consumption and operational range. They would strip the transmission down to individual gears and bearings, documenting every tolerance and measuring every wear pattern. They would simulate the kind of sustained operation that German vehicles faced on the eastern and western fronts, running the King Tiger until systems failed, and recording exactly how and when things broke. The tests would reveal something that would change how British and American planners thought about German heavy armour. But that discovery still lay ahead, hidden in numbers that hadn't been measured yet, waiting in components that hadn't been stressed to failure yet. For now, the King Tiger simply sat there in the late summer sunshine, looking every bit like the superior weapon everyone believed it to be. Its reputation preceded it. Allied tank crews feared it. Intelligence officers studied it. War planners worried about encountering more of them. The testing would determine whether that fear was justified or whether Germany's ultimate tank was actually a masterpiece of engineering applied to the wrong problem. Chief Engineer Robert Pritchard arrived at Chobham's vehicle testing facility at 0700 hours on August 28, 1944. He'd spent 20 years designing luxury automobile transmissions for Rolls-Royce before the war convinced him that engineering skills served better purposes than making cars for wealthy customers. His team consisted of mechanics and engineers recruited from Britain's automotive industry. They understood production engineering the way infantry understood rifles. They knew that impressive specifications meant nothing if you couldn't manufacture thousands of vehicles or maintain them when components failed. The King Tiger waited on the test pad, radiating the kind of intimidating presence that made Allied tank crews report, sightings with genuine anxiety in their voices. Pritchard walked around it slowly, taking in details that would matter once testing began. The Schachtelaufwerk overlapping road wheel system created that characteristic low ground pressure German engineers bragged about. The armour plates met at angles, suggesting someone had calculated optimal protection geometry rather than simply welding thick steel together. Even the tool stowage looked designed by people who cared about aesthetics as much as function. But Pritchard also noticed things that troubled him professionally. The track pins showed unusual wear for a vehicle with only 61 kilometers of operation. The engine access panels had been opened repeatedly, far more than normal post-delivery inspection would require. Oil stains around the transmission housing suggested leaks that German mechanics had been managing rather than repairing. The maintenance log told a story of escalating crisis, not routine service. At 0830, Pritchard climbed into the driver's seat for the first test. Acceleration from 0 to 30 kilometers per hour on level pavement. Chobham ran this test on every vehicle because it revealed fundamental truths about power-to-weight ratio, transmission efficiency, and whether an engine could deliver battlefield performance rather than just theoretical capability. He started the Maybach HL 230 P30 engine. The V12 came to life with the deep rumble of an engine built by people who understood precision manufacturing. 690 horsepower at 3,000 revolutions per minute, more power than most Allied tanks possessed. Pritchard engaged first gear and released the clutch. The King Tiger began moving forward with surprising smoothness for a 70-ton vehicle. The acceleration felt adequate through first gear. Then Pritchard shifted to second. The transmission engaged with a grinding sensation that shouldn't exist in a vehicle with minimal to-land mileage. He pressed the accelerator harder. The engine revved, but the tank's acceleration remained sluggish, as if the transmission was absorbing power rather than transmitting it to the tracks. At 14.7 seconds, the King Tiger finally reached 30 kilometers per hour. Pritchard let off the accelerator and brought the massive tank back to the starting line. He shut down the engine and sat there for a moment, thinking about what those numbers meant. His team gathered around with clipboards and stopwatches, waiting for his assessment. "The transmission is dying," Pritchard said quietly. "Gear engagement feels like there's already significant wear on the synchromesh assemblies. The vehicle barely has 60 kilometers of operation, and it's showing symptoms you'd expect after thousands." The numbers explained part of the problem. The Maybach engine produced 690 horsepower. The vehicle weighed 69.8 tons, fully loaded with ammunition and fuel. That gave it a power-to-weight ratio of 9.9 horsepower per ton. For a heavy tank designed to break through enemy defensive positions while maintaining mobility, that ratio was borderline inadequate. But the deeper problem wasn't the engine. It was the transmission struggling to convert that power into movement. Pritchard's team prepared a British Cromwell tank for comparison. This wasn't entirely fair. The Cromwell weighed only 27 tons, less than half the King Tiger's mass, but it represented what British factories could produce in quantity, using proven components and maintainable systems. The Cromwell's Rolls-Royce Meteor engine, a detuned version of the Merlin aircraft engine, produced 600 horsepower. Its Merritt Brown transmission had been designed specifically for tank use, incorporating lessons learned from years of armoured warfare. The Cromwell completed the 0 to 30 km/h acceleration in 7.2 seconds. The difference wasn't subtle. It was the gap between a vehicle designed for mobile warfare and one designed for maximum firepower and protection at the cost of everything else. The King Tiger's impressive armour and devastating gun came with fundamental mobility compromises that mattered enormously on battlefields where tactical speed meant survival. Top speed testing revealed even more troubling numbers. On Chobham's test track, the King Tiger managed 34 km/h before the Maybach engine hit its power ceiling, and the struggling transmission refused to transfer more thrust to the tracks. The Cromwell reached 61 km/h without straining. The gap represented the difference between a vehicle that could exploit tactical opportunities and one that arrived late to every engagement. Then Pritchard ran the cross-country mobility tests that would reveal the King Tiger's fundamental flaw. Chobham's test course included sections simulating European terrain, muddy fields, like those in Normandy, rolling hills similar to the Ardennes, the kind of varied ground where tanks actually fought rather than the perfect surfaces where specifications were measured. The King Tiger managed 12 km/h average across rough terrain. Fuel consumption climbed to 190 litres per 100 kilometres. The massive weight and struggling transmission meant the engine worked constantly at high output, burning fuel at rates that made operational deployment questionable even before mechanical reliability entered the calculation. After the third cross-country run, something happened that confirmed Pritchard's worst suspicions. The transmission began making sounds that no transmission should make, a grinding, chattering noise from deep inside the gearbox housing, metal-on-metal contact where oil film should have been preventing wear. Pritchard stopped the test immediately and ordered the power pack removed for inspection. The Maybach OG 402312 transmission came out of the King Tiger's hull the following morning. German engineers had designed it specifically for this tank, strengthening gears and bearings to handle 70 tons of combat weight. 8 forward speeds and 4 reverse speeds provided theoretical flexibility for tactical movement. The semi-automatic pre-selector system allowed drivers to choose gears in advance, reducing shift time during combat. On paper, the transmission represented sophisticated engineering applied to heavy tank requirements. In reality, it represented catastrophic overcomplexity applied without adequate testing. Pritchard's team disassembled the transmission with the careful precision of surgeons examining a patient who died from mysterious causes. What they found inside the housing shocked even mechanics who'd spent years diagnosing automotive failures. The synchromesh assemblies for third gear were destroyed. Bronze synchronizer rings meant to smooth gear. Engagement had worn completely through, allowing hardened steel gears to grind directly against each other. The damage extended to fourth and fifth gears, where wear patterns indicated the transmission had been operating with minimal lubrication, despite adequate oil levels. The pre-selector mechanism, that sophisticated innovation that was supposed to provide smooth shifts, had failed partially. Springs and detent balls showed stress fractures that shouldn't exist after minimal operation. Most damning, the main shaft bearings showed spalling. Small fragments of hardened steel had separated from the bearing races, creating rough surfaces that accelerated wear exponentially. This was the kind of failure that happened after years of hard use, not weeks of limited operation. The bearing metallurgy was wrong. Someone at the Zahnradfabrik transmission factory in Friedrichshafen had made decisions about heat treatment or material specification that created components unable to survive the stresses they'd be subjected to during actual use. Pritchard requested manufacturing documentation through intelligence channels. British agents operating in Sweden had cultivated contacts with German engineers who travelled there for business purposes. Within 2 weeks, detailed specifications for the OG 402312 transmission arrived in Chobham, smuggled out of Germany by people who understood that technical information could shorten the war more surely than sabotage. The documents revealed something extraordinary. The transmission had never been tested to failure during development. German engineers had calculated theoretical load capacities based on material properties and gear geometry. They'd run limited trials using controlled conditions that didn't simulate sustained combat operation. The King Tiger had entered production with a transmission that existed primarily on paper, its real-world reliability unknown because no one had stressed it until it broke. This wasn't engineering. It was gambling. Germany had bet that calculations would prove accurate, that materials would perform as specified, that assembly quality would remain consistent across production runs. The transmission failing after 48 kilometers proved that bet had been catastrophically wrong. Pritchard made careful notes in his test report, choosing words that would convey the significance without inflammatory language. He wrote, "The King Tiger's transmission represents complex engineering inadequately tested before production. Fundamental design flaws in bearing selection and gear metallurgy create reliability problems that render the vehicle unsuitable for sustained combat operations. The British Army should not expect German heavy tanks to maintain mobility during extended campaigns. Their transmissions will fail before their armour or weapons systems become combat ineffective." The fuel consumption testing revealed another critical vulnerability. The King Tiger carried 860 litres of fuel in tanks distributed throughout the hull. At the observed consumption rate of 190 litres per 100 kilometres during cross-country operation, that fuel provided a theoretical range of 450 kilometres, but that calculation assumed perfect conditions, minimal combat manoeuvring, no sustained high-speed operation. Real battlefield conditions would reduce that range dramatically. A King Tiger company advancing across France would need fuel resupply every 2 to 3 days of active operations. German logistics, already strained by Allied air attacks and partisan activity, couldn't sustain that consumption rate across dozens of heavy tanks. The most powerful tank in the Wehrmacht arsenal would spend more time waiting for fuel trucks than engaging enemy armour. Pritchard's team ran cold weather simulations that revealed yet another fatal flaw. Chobham's environmental chamber could simulate temperatures down to 40 degrees below 0 Fahrenheit. Intelligence reports from the Eastern Front described German vehicles suffering catastrophic failures when temperatures dropped, particularly tanks with complex overlapping road wheel systems. The King Tiger entered the chamber after being driven through artificial mud, allowed to freeze overnight at 10 degrees below 0. The next morning, mechanics attempted to start the engine and move the vehicle. The Maybach engine started after extended cranking, its cold oil barely flowing through passages designed for moderate climates. But the transmission wouldn't engage. The oil had thickened to the consistency of tar, preventing the hydraulic systems from functioning. The overlapping road wheels, caked with frozen mud, had locked solid. Ice bridged between individual wheels, transforming the sophisticated suspension into an immobile sculpture. Pritchard's team spent 4 hours with blowtorches and de-icing equipment, carefully warming components until the King Tiger could move again. This was the same problem that immobilized German armour across Russia every winter. The same design philosophy that valued performance over maintainability, sophistication over reliability. A Soviet 34 tested under identical conditions started normally and drove away after mechanics cleared ice from the tracks with hand tools, a process that took 17 minutes. The armor protection analysis destroyed another piece of conventional wisdom about the King Tiger's invincibility. Allied intelligence had been reporting that the sloped frontal armor was proof against every anti-tank weapon in service. Pritchard's metallurgical team subjected armor samples to detailed analysis, measuring hardness, checking for proper heat treatment, examining weld quality. The frontal glacis, sloped at 50 degrees from vertical, measured 150 millimeters thick. The angle increased effective thickness to approximately 240 millimeters against flat trajectory shots. That protection would indeed stop American 76 millimeter armor-piercing rounds at normal combat ranges. It would defeat British 17-pounder shots beyond 1,000 meters. The armor worked exactly as designed, but the welds connecting armor plates showed disturbing irregularities. Quality control at Henschel's factories had deteriorated as Germany's strategic situation worsened. Experienced welders had been conscripted into combat units, replaced by workers with minimal training. Some welds showed incomplete penetration, creating potential fracture points where armor-piercing rounds might separate plates even without penetrating them. The side armor, 80 millimeters thick and vertical, could be penetrated by Allied tank destroyers at ranges under 800 meters. The King Tiger's invincibility existed only from the front and only against weapons fired from beyond effective Allied engagement ranges. On September 7, 1944, Pritchard designed a final test that would prove everything the data suggested. The King Tiger would run a 500-kilometer endurance trial, continuous operation over varied terrain with minimal maintenance, replicating combat conditions where mechanics couldn't perform scheduled service and vehicles had to keep moving regardless of developing problems. The test began at 0600 hours. By hour 18, transmission oil temperature was climbing above acceptable limits. The stressed gearbox was generating more heat than the cooling system could dissipate. Pritchard's team monitored the temperature carefully, knowing that overheated transmission oil lost its lubricating properties and accelerated wear catastrophically. At hour 22, the transmission failed completely. Third gear, already damaged during earlier testing, disintegrated under sustained load. Bronze fragments from destroyed synchromesh assemblies contaminated the oil, spreading debris throughout the gearbox. The grinding became so severe that Pritchard ordered the test stopped before the entire transmission destroyed itself. The King Tiger had covered 48 additional kilometers before terminal failure. Combined with the 61 kilometers of German operation, the vehicle had managed 109 kilometers total before becoming immobile. Pritchard sat in his office that evening, writing the technical report that would reach British Army headquarters and American intelligence within days. He chose his words with the precision of someone documenting evidence that contradicted everything Allied planners feared about German heavy armor. He wrote, "The King Tiger represents sophisticated engineering, catastrophically undermined by inadequate development, testing, and declining German production quality. The transmission, central to the vehicle's tactical mobility, fails after minimal operation due to fundamental flaws in bearing selection, gear metallurgy, and lubrication system design. The tank's impressive firepower and armor protection are rendered irrelevant by its inability to reach and remain on the battlefield. British and American forces should anticipate that German heavy tank units will suffer severe mobility problems during extended operations. Their most powerful weapons will be defeated not by Allied firepower, but by their own mechanical unreliability. The test data proved something that would influence Allied planning for the remainder of the war and shape military procurement decisions for decades afterward. Sophistication without reliability lost battles. Maximum firepower and protection meant nothing if the vehicle couldn't reach the fight or remain operational once it arrived. The King Tiger was a masterpiece of armored engineering that had failed at its most basic requirement, getting to the battlefield and staying there. Pritchard requested production data that would reveal the industrial story behind the mechanical failures. Individual vehicle performance mattered, but wars weren't won by individual tanks. They were won by industrial capacity, by which side could build more equipment faster and keep it operational under conditions that destroyed anything not designed for sustained use and field repair. The numbers that arrived from British intelligence and through neutral Swedish contacts painted a picture that went far beyond transmission failures and fuel consumption. They revealed two completely different philosophies about how to fight an industrial war, and why one philosophy was winning while the other collapsed under its own sophistication. Germany began producing the King Tiger in January 1944. That first month, Henschel managed to build just 3 vehicles. Production climbed slowly, as workers learned the complex assembly procedures and suppliers delivered the specialized components. By March, monthly output reached 12 tanks. April saw 15 vehicles completed. May brought 18 King Tigers off Henschel's assembly lines. From January through December 1944, Germany produced exactly 489 King Tigers. Total production through war's end in May 1945 barely exceeded 490 vehicles. Nearly a year and a half of manufacture delivering fewer than 500 tanks, each one consuming resources and specialized labor that could have built thousands of simpler, more reliable vehicles. American Sherman production told a radically different story. The Fisher Body Division of General Motors alone produced 11,200 M4 Shermans in 1944. Chrysler's Detroit Arsenal added another 8,000 vehicles. Ford's factories contributed thousands more. Total American tank production in 1944 exceeded 29,000 units, and that number didn't include British production, Canadian manufacturing, or Soviet output. The gap wasn't just factory capacity. It was design philosophy, whether you engineered vehicles for perfectionist performance or for production reality. The Sherman prioritized mass manufacturing over individual capability. 63% of Sherman components came from commercial automotive production, meaning American factories didn't need to design and manufacture unique parts when existing industry components worked adequately. The hull consisted of large welded sections rather than the complex angles the King Tiger required. Bolt-together construction meant sub-assemblies could be manufactured in different facilities and shipped for final assembly. Modular systems allowed mechanics to replace entire components rather than repairing individual parts. 87% of maintenance required standard wrenches and tools every motor pool already carried. German design principles valued optimization through engineering excellence. The King Tiger's complex armor geometry provided maximum protection through deflection angles calculated with mathematical precision. Welded monocoque construction created structural strength at the cost of repair complexity. Integrated systems required specialized knowledge to service. The Maybach transmission alone contained 847 unique components, each manufactured to tolerances measured in hundredths of millimeters. Pritchard calculated real-world maintenance requirements based on Chobham's testing and the combat logs from the captured vehicle. The King Tiger required an average of 38 man-hours of monthly maintenance, and that maintenance needed skilled technicians who understood the vehicle's sophisticated systems. A Sherman needed 14 man-hours per month using general mechanics with basic automotive knowledge. Parts availability revealed another critical gap. 91% of Sherman parts could be sourced from standard military supply stocks or fabricated using common materials and tools. Percent of King Tiger parts required factory orders through German supply chains that stretched across occupied Europe and were under constant attack from Allied aircraft and partisan forces. The tactical mathematics were devastating. A British armoured regiment required 52 tanks to be fully equipped. Using Chobham's maintenance data, that regiment needed 728 total man-hours monthly to keep its Shermans or Cromwells operational. A German heavy tank battalion with 45 King Tigers required 1,710 man-hours, more than double the maintenance labour for slightly fewer vehicles and significantly less tactical flexibility. Those extra hours came from somewhere real. They meant mechanics working through the night instead of sleeping. They meant tank crews pressed into service as assistant mechanics instead of training for combat. They meant battalion commanders choosing between maintaining vehicles and maintaining combat readiness. A choice that shouldn't exist, but became routine in German armoured units by late 1944. The transmission failure rate proved particularly catastrophic for German operations. Intelligence reports from the Western Front, compiled from interrogations of captured German tankers and examination of abandoned vehicles, revealed a consistent pattern. King Tigers were being left behind during retreats, not because they'd been damaged by enemy fire, but because their transmissions had failed, and German recovery vehicles couldn't tow 70-ton tanks across battle-damaged terrain. Of the 489 King Tigers produced through December 1944, Allied intelligence estimated that fewer than 200 remained operational by January 1945. The losses weren't combat destruction, they were mechanical attrition. Transmissions failing, final drives breaking, engines seizing from inadequate lubrication systems. The sophistication that impressed everyone in intelligence photographs was killing German armoured capability more surely than Allied gunfire. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The human cost of these competing philosophies played out in ways that never appeared in after-action reports or intelligence summaries. German heavy tank crews didn't lose battles because they had inferior weapons. They lost battles because their superior weapons couldn't get to the fight or couldn't stay in the fight once they arrived. A King Tiger company at full strength with 14 tanks could expect 7 or 8 vehicles operational on any given day by autumn 1944. The rest sat immobilized, waiting for transmissions that would never arrive, or spare parts that existed only in German factories that Allied bombers had turned into rubble. An American tank company with 17 Shermans could expect 15 vehicles ready for combat, and when Shermans broke down, they could often be repaired using parts cannibalized from other damaged vehicles or fabricated in field workshops. The Battle of the Bulge in December 1944 demonstrated these principles with brutal clarity. Germany committed its last strategic reserve, including newly formed heavy tank battalions equipped with King Tigers, in a desperate offensive designed to split Allied armies and recapture Antwerp. The initial attacks achieved tactical surprise and significant gains. German armour broke through American lines in the Ardennes, creating the bulge that gave the battle its name. But within days, the King Tigers began failing. Not from American fire, though tank destroyers and fighter bombers claimed their share, but from the mechanical stress of sustained operations. Transmissions overheated during long approach marches. Final drives failed when tanks attempted to climb the steep Ardennes hills. Fuel consumption exceeded German logistics capacity to deliver supplies forward. By December 26th, many German heavy tank units were reporting less than 30% operational readiness. American armoured divisions, despite suffering heavy casualties during the initial German assault, maintained 60 to 70% readiness through the entire battle. The difference was maintainability, parts availability, and design philosophy that valued keeping adequate numbers of tanks running over fielding small numbers of superior vehicles. Pritchard's Chobham report reached American intelligence through liaison channels in early October 1944. Engineers at the Aberdeen Proving Ground in Maryland, who'd been conducting parallel testing on a King Tiger captured near Aachen, found their results matched British findings almost exactly. The transmission failed after minimal operation. The fuel consumption made operational deployment questionable. The maintenance requirements exceeded what field units could provide. The American report added one additional damning observation. The King Tiger's 88mm gun, while devastatingly effective against Allied armour, fired ammunition so heavy that crew fatigue limited combat effectiveness. Each armour-piercing round weighed 23 kilograms and stood nearly a metre tall. The loader, working in the cramped turret, would be exhausted after firing 24 rounds. A Sherman's 75mm ammunition weighed 6.3 kilograms per round, allowing sustained combat operations without crew fatigue becoming a limiting factor. The strategic implications became clear to Allied planners. German heavy tanks were fearsome weapons when they worked, and when they could get fuel, and when their crews weren't exhausted from maintaining dying vehicles. But those conditions existed less and less frequently as the war progressed. Allied tactics evolved to exploit German mechanical unreliability, bypass heavy tank positions when possible, forcing them to relocate and stress their fragile transmissions, attack German fuel supplies and supply lines, knowing King Tigers consumed fuel faster than German logistics could deliver it, maintain operational tempo that prevented German mechanics from performing the constant maintenance their sophisticated vehicles required. The King Tiger represented everything people believed about German engineering superiority: massive armor protection, devastating firepower, sophisticated systems designed by brilliant engineers. But Chobham's testing and battlefield reports were proving that belief catastrophically wrong. The most feared tank in the German arsenal was actually a maintenance nightmare that consumed resources Germany couldn't afford to spend, broke down before reaching combat, and required specialized support that didn't exist in a collapsing industrial base. By February 1945, as Soviet armies closed on Berlin from the east and American and British forces advanced from the west, King Tigers were being abandoned across Germany. Not destroyed in combat, but left behind when their transmissions failed or fuel ran out or spare parts proved impossible to obtain. The tanks designed to stop Allied advances were stopping themselves through mechanical complexity that peacetime development could have identified and corrected, but wartime urgency had allowed to reach production. Pritchard sat in his Chobham office in March 1945, updating his technical report with data from the final months of European combat. He wrote a supplementary analysis that tried to capture what the numbers meant beyond technical specifications. The King Tiger proves that maximum capability in individual weapons is meaningless without the industrial capacity to produce those weapons in adequate numbers and the logistical capability to sustain them in combat. The Sherman and 34 prove that adequate weapons produced in fair, overwhelming numbers will defeat superior weapons produced in limited quantities every time. This is not a new lesson. It is perhaps the oldest lesson in industrial warfare, but Germany chose to ignore it, and that choice cost them the war more surely than any single battle. The production numbers told their final story. By war's end in May 1945, Allied factories had produced approximately 49,000 Sherman tanks. Soviet industry had built 57,000 34s. Combined Allied tank production exceeded 150,000 vehicles of all types. Germany had produced 490 King Tigers, the ultimate expression of their heavy tank philosophy. But those numbers revealed only part of the gap. Of the 49,000 Shermans, approximately 41,000 remained in service in May 1945, an 84% survival rate. Of the 490 King Tigers, intelligence estimates suggested fewer than 150 remained operational, a 30% survival rate. The difference wasn't combat destruction, it was design philosophy, the choice between sophisticated perfection that broke constantly and adequate reliability that kept fighting. The Shermans served through the Korean War. Israel used them through the 1960s, regunning them with more powerful weapons, but keeping the reliable mechanical systems that made maintenance straightforward. Some remained in service with smaller armies into the 1970s. The vehicles proved so durable, so maintainable, so adaptable, that they outlasted the war they were designed for by 3 decades. The King Tiger died with the Third Reich. A few captured examples were tested by Soviet and American engineers, then relegated to museums. The sophisticated engineering that impressed everyone couldn't overcome fundamental flaws in transmission design and the impossibility of maintaining complex vehicles when industrial infrastructure collapsed. The last operational King Tiger fired its gun in anger in April 1945, defending Berlin against Soviet armor. Within weeks, it was abandoned when its transmission failed, and German mechanics had no parts to repair it. The lessons embedded in the King Tiger's failure extended far beyond tank design to fundamental questions about military procurement and industrial warfare. Chobham's testing had proven something that would influence American and British military thinking for generations. Engineering for reliability beat engineering for maximum capability. Weapons you could build in thousands and maintain in the field defeated weapons that performed better on paper but broke constantly and required specialized support. The factory worker who could assemble 10 adequate tanks proved more valuable than the master craftsman who could build one perfect tank. The mechanic who could repair a Sherman with standard tools and automotive knowledge proved more decisive than the specialist who understood King Tiger transmissions but couldn't get parts or time to perform proper maintenance. September 1945, 4 months after Germany's surrender. The King Tiger, used in Chobham's testing, sat in an outdoor storage yard, its testing complete. Nearby, a Sherman tank rumbled past, heading to the docks for shipment to occupation forces in Germany. The American tank looked crude next to the German vehicle's precision engineering. Its armor was thinner, its gun less powerful, its engineering less sophisticated. But the Sherman was running. It had been running continuously for 3 years of production. It would keep running for decades more. The King Tiger, with its 48 kilometers of operation before terminal transmission failure, sat silent. A monument to engineering brilliance applied without strategic understanding, a masterpiece that had failed at the only thing that mattered, fighting and winning a war. Chief Engineer Robert Pritchard's final report concluded with words that would be quoted in military procurement debates for the next 80 years. In war, the adequate weapon that works defeats the perfect weapon that breaks. The King Tiger was perfect. The Sherman was adequate. History records which one won. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.